To understand what minerals are, we first have to break them down and see what they're made of. And on this screen, we have a visual of that. Rocks are the big topic. And then, like we talked about, rocks are made of minerals. All minerals are made up of different elements, and then elements are made of atoms. So what is an atom? It's the smallest part of an element that has all the properties of that element. Everything on the world is made up of atoms. An element is a pure substance that can't be broken down into simpler substances by ordinary chemical means. Elements are natural, they're found in nature, although some of them are made in the laboratory. And they are all organized according to their properties, meaning that all the gases are together, all the metals are together, and they are all organized into a chart called the periodic table of elements. And there's a copy of this in the reference section of your agenda. Now, when elements come together, they can make up minerals. So what's a mineral? Well, here's the definition we're going to use. It's a naturally formed inorganic solid that has a definite crystalline structure. And what I've done here is I have broken apart the definition into smaller phrases. And when we understand what those phrases mean, we get a better picture of what a mineral is. So the first phrase, naturally formed, means that they are found in nature. Humans don't make them. Minerals cannot be made in the lab. If it is, it's not a mineral. Secondly, they are inorganic. This means that minerals are not living. Now, don't get confused here and think that minerals are dead, because if something's dead, it means at one point it was living. But in this case, minerals are not alive or dead, they just exist. Third, minerals are solids. They will only be found in a solid state of matter. So if you're trying to decide if something is a mineral and it happens to be a liquid or gas, you know it's not a mineral. And then lastly, all minerals have a definite crystalline structure. This just means that the molecules that make them up are arranged in patterns. So part of our definition said that minerals have a definite crystalline structure. You've probably heard of a crystal. You might have even seen some if you've gone to a gift shop, or maybe if you've gone mining or panning for different minerals, you might have seen crystals, very shiny and reflect light. But in this case, crystal really is referring to more of a shape. It's a solid geometric form of a mineral made by repeating patterns of atoms or molecules. So what we see on this slide are different examples of crystals. All of these are crystals because, like I said, crystal in this case really refers to a shape. So there's different shapes that you can see here. Minerals are based on what they're made of, based on their chemical composition. That word composition simply just means what something is made of. And we can put minerals into two groups. All minerals will fall into one of these two groups. They are either a silicate or non-silicate. So what in the world does that mean? Well, if a mineral is classified as a silicate, it means that it is made up of silicon and oxygen. Both of those are elements. If a mineral is non-silicate, then that mineral does not contain silicon and oxygen. And those two elements are important because they are abundant in most living things. There are hundreds of minerals, and when you find a mineral in nature, it doesn't come labeled telling you exactly what you have found. And many minerals look very similar to each other. So then how do we tell them apart? Well, one way we tell them apart is by performing different sort of tests on them, and we call these mineral identification tests. The first test is simply looking at the color of the mineral. Color is obviously what you see when you look at it, color that's on the outside. This is really one of the most unreliable test to do on a mineral, at least if you use it by itself. If you use it in combination with some of the other tests we're going to look at, then it could have some benefits. Another mineral identification test we can do is looking at the luster of a mineral. Luster simply means how it reflects light. All minerals have a luster, and there's two types of luster. A mineral can either be metallic or non-metallic. And it kind of sounds like what the word sounds like. If a mineral has a metallic luster, it's more shiny. It reflects light. You can kind of see the word metal in metallic, which means the opposite is true for non-metallic. If a mineral has a non-metallic luster, it just means that it doesn't reflect light. Streak is another way we can identify minerals. Streak is what the color of the mineral is in a powder form. We'd said earlier that color, just looking on the outside, isn't always the best indicator. Streak is really more reliable because it kind of takes the color from the inside. So in this picture here, what we have are two mineral samples, and you can see that they have been rubbed across a tile set in front of them. And you can see the color on the tile is similar to the color of the mineral, but in the case of the one on the right, my guess is that is the mineral hematite. Hematite has sort of a dark color on the outside, but its streak is more of a maroon or burgundy color. These next two mineral identification tests kind of go together. Both of them have to do with the way that minerals break. So a mineral can break one of two ways. If a mineral breaks with cleavage, it means it breaks with very even surfaces or very flat surfaces. So the picture on the bottom left looks like a cube. This mineral most definitely has cleavage because we can see very flat surfaces on the majority of the mineral. The picture in the middle also represents cleavage. This is the mineral mica. And this mineral peels off in sheets or layers, almost like how you would peel an onion with different layers. That's another example of cleavage. Now, if a mineral does not break with even surfaces, then we say it has fracture. And that just means that it breaks uneven. It has very bumpy, rough, jagged surfaces, like the picture on the bottom right. The next mineral identification test is called hardness. Hardness means how easy the mineral can be scratched. And in this picture here, we see that this person is holding a mineral and using their fingernail to scratch the mineral. Well, that tells us that the mineral is pretty soft, is something as soft as your fingernail can scratch it. And to measure the hardness, we rank minerals on a scale. And the scale is called the Mohs, M-O-H-S, Mohs hardness scale. And this is what geologists use to determine the hardness of minerals. And so they rank it. If it's a lower number, somewhere around 1, then it's very, very soft. The scale goes to 10. So anything higher, on the higher end of the scale, would of course have a very high resistance to being scratched. It's very hard. So here is a copy of the Mohs hardness scale. There are many different versions of this scale, but they all measure minerals the same way. They rank them 1 to 10, 1 being very soft, 10 being very hard. And if you look at the scale, number 1 is the mineral talc. This is actually the mineral that's used to make baby powder. So if you've ever felt baby powder, you know how soft it is. 10 being a diamond. Of course, diamonds are the hardest mineral, and the only thing that can scratch a diamond is another diamond. Now, this should look very familiar to you. We just talked about density in our last unit. But density is another way that we can identify minerals. Remember, density is how much matter is in a space, almost like how how much the mineral is on the inside, how tightly packed together all the elements and all the atoms are on the inside. And just as we did in our last unit, we're going to use the same formula to find density. So you would find the mass of the mineral by putting it on a triple beam balance, and then we would find the volume, or how much space it takes up, and divide those two numbers to find its density. The last way we identify minerals is any special properties that minerals have. That just means that there are some minerals that do something or have a special uniqueness about them that no other mineral has. So here's some examples that you can jot down. Fluoresce means sort of to glow in the dark. There's some minerals that are very bright, and when you turn out the lights, they almost seem to shine. They glow in the dark. Magnetite is a mineral that happens to have a magnetic property to it, and some minerals actually have a unique taste. One of those is howite, and howite is used to make your everyday table salt. Now, before we can do any of these mineral identification tests on a mineral, we have to get it out of the ground, and that is done by two ways. Surface mining is basically mining that's done on the surface of the earth or very close to the surface, whereas subsurface mining is done way below where miners work, and you have to go into mines underground to dig them out. And then lastly, how do we use minerals? Well, we use them really in our everyday life. We use minerals all around us. Some minerals that are metallic, not necessarily just shiny like we talked about earlier, but they have a metal quality to them, are good conductors of electricity. And so you would see those in planes and cars and different parts of your computer. And the opposite, of course, non-metallic minerals are good insulators, meaning they don't allow electricity to travel through them. So a lot of our roads are made from minerals that are non-metallic, buildings and bridges. And then finally, really kind of just for fun, minerals are used as gemstones, meaning that we use them because they're very pretty to look at or because they're very rare. So this is where most of your jewelry comes in, diamonds and rubies and sapphires.